Good morning. My name is Atanas Popov. I am with Idera. Thank you so much for having me. Now let me make sure that my video works and hopefully I can start. All right. I hope you can see me now. Try to make myself small. Right. So today we're going to speak about low code and how it relates to RAD as it in RAD Studio and no code, and what are the differences. The topic has been very hot for quite a while now all over the world, and I think that it will be interesting to expose this content to our customers. Before I start with the body of this presentation, I want to spend a few minutes to introduce myself and speak a little bit about Idera's developer tools business. I joined Idera about 5 years ago to build our developer tools business, starting with Embarcadero, which delivers Delphi, C++ Builder, RAD Studio, and Interbase. Since the time that we started building this part of Idera, we have done quite a bit. We expanded our IDEs and tools business of Embarcadero to include Whole Tomato. We also acquired a number of companies and tools in the JavaScript or web development space, including Sencha, Fusion Charts, and Fruala. A few years ago, acquired our first low-code solution under the Lanza brand name. Most recently, a couple of months ago, in fact, we acquired an API business called API Layer that specializes in a number of data APIs, such as geolocation and exchange rates. Over this all this time, we have had one single theme, which is that Idera's DevTools is focused on developers. In fact, you can see this rather large magnifying glass on the developer here, because in fact, developers are our superheroes. We love developer tools, and we're very proud to have some brands that have been around for a really long time, including Delphi, which just turned 26 years old, and it keeps getting younger. As you can tell from some of the pictures here, our team is very passionate about our products and also likes to have fun. I think some of these pictures are of our Japanese team from some of our events, and they've been creative and even built some anime characters to represent our products. So you can tell that we are really passionate about developer tools. What I want to spend time today is speak about low code, and I will start with a little bit of history. Then I'll speak about the differences between low code and no code, and there are quite a few, and then relate this to what is RAD Studio itself and how that fits into the picture. I'll cover some specific features of low code systems and some themes that are useful for you to consider when thinking about low code. So to start with, let's look a little bit at the history. In fact, low code is not new. This is very similar to many of the tech trends out there. Low code has been around as early as the 1980s. Low code finds its roots in a term called fourth generation languages, and those have been a while since, I guess, first mentioned in the early 80s. And just as a comparison, Delphi was created in 1996. So a lot of the languages that we're familiar and are using today are in fact younger than, older than low code. So that's kind of interesting to know. If you think about, so a little bit about how this generation of programming languages work. You may know this, but I find it interesting. There's a lot of literature about it. In essence, there are two levels of languages: low level, which are very close to the machines, such as assembly, and then there are the higher languages. And they are split in several categories. The third generation are languages that we're probably most familiar with, such as C and C++, C#, Delphi. Those are a lot of the hardcore languages that traditional developers use. The fourth generation languages are languages that are a lot more human-like. The idea is that an idea that has been around since the beginning of programming languages is to be able to speak to computers in the way that we speak English, essentially, or our own languages. And fourth generation languages do that. The fifth generation that are noted here are leverage even more visual tools. But the fact of the matter is that fourth generation languages, as we see here, have evolved to become low code and rely very heavily on visual interfaces. There are many fourth generation languages. I picked up this slide from Wikipedia, and it lists some of them, but there are quite a few more. Literally, there are dozens and dozens of fourth generation languages. What is unique about fourth generation languages, unlike some of the third generation languages such as C++ and Delphi, is that these languages are more topical. They are more use case based, or the majority of them. A lot of them originated early on around the need to manipulate data. So if you look down to my left, I guess you're right, you note some languages such as R and SAS that have been very, very popular for statistics, but also some other languages that are very popular for reporting and data generation. Over time, there obviously have been very successful mathematical languages such as MATLAB and Mathematica, some very specific database querying languages such as SQL and less known ones such as information builders Focus. And there are those that are more general use, which you'll see in the general use more of the languages that are today known as low code. You'll note Lanza is highlighted there. That's one of the companies that we own, but there are a number of other ones there. So if you look at this slide, I picked up just the low code ones that are popular these days. And again, this list is not inclusive in any way, but it does note some of the better known names. Such as Appian, OutSystem, Pega, Mendix, Lanza, Progress, ServiceNow. These are all today representing some of the most popular low-code solutions that are out in the marketplace. What is important to note about fourth generation languages or low-code languages, that in many ways they're built on top of existing third generation languages. So if you look at Lanza, the majority of Lanza is built essentially is an abstraction of C++. Mendix has a lot of Java and JavaScript. OutSystems have, I believe, C#. So a lot of these are dependent on each other, but they instrument far more than the underlying lower level language. They're built so that they can instrument middleware, databases, and help build holistic applications. So I like using this slide because it really kind of nicely represents what low code really is, at least to me. I'm borrowing it from our Lanza pitch deck, which obviously is a sales deck, but it speaks to the fact that if you look at traditional software development, you usually rely on a lot of technologies or tool chains to build an application. What that means is that you usually need different types of experts that can do the front end part, the database part. In some cases, separate people will build the middleware, and you may mix and match multiple different technologies. In fact, you generate more code and the teams are larger. What low code does is that in a way, it hides the complexity of all these detailed technology stacks and abstracts them into much simpler scripting languages or visual interfaces. Those can be implemented by a lot fewer developers. So instead of having teams of dozens of people, you actually would have a fraction of that team that can do the same with a low code. Additional advantages to that are that the business teams that create the requirements and interact with the developers could be also smaller. So low code is simpler ways to build applications and saves you a lot of resources. And that is why today it is so popular, because developers are a scarce resource and people want to be able to build apps in a different way. What is the difference between the nuances of low code? That's a frequently asked questions, because if you look out there, in addition to the term low code today, there are a number of other terms, such as no code and most recently hybrid low code. So what are the differences? This table does a nice job to specify some of the criteria that differentiate the different approaches to building an application. A traditional coding application usually is slower to build and requires more resources, which I already mentioned. A no code, which essentially means that you're instrumenting the application building process without writing code, but relying on visual interfaces and configuration, is very fast to develop. But in many cases, because of the constraints of the interface or the instrumentation mechanisms, you have some limitations on what you can do. Frequently, the applications are less extensible. In other words, they cannot connect to so many things, or they have fewer functionalities because of the constraints of how the low-code interfaces are built. When you go into what is known as pure low-code, and again, these differentiations are not as clear-cut, and there is a lot of gray in between them. I think that pure low-code has more extensibility, but still there are functionality constraints, because the idea is that you cannot so easily write code within the low-code systems to extend the functionality. A simpler example would be, for example, if you look at building a JavaScript a web application, and you want to have a very unique behavior on the web client, well, you may or may not be able to enable that within the low-code visual interface. If you want a special animation or something else, you may actually need to write straight JavaScript code in addition to your low code. Hybrid low-code systems allow you to do this more seamlessly within the framework of the low-code and not outside, which is important from a standpoint of how you're going to maintain the application in the future. Probably the most important differentiation between low-code and no-code that we think about is the fact that no-code targets, if you will, citizen developers or people that without formal programming education. It is very attractive to be able to think that you can build applications without the need of the scarce resource, which is developers. And if you look at some of the brand names in that space, a lot of the large technology companies are trying to address this need because the market is so scalable. However, there are a lot of limitations to these approaches. You cannot build everything with no code. So low code is still popular, but low code requires some IT still. So even though a lot of these systems out there, including OutSystem and Lanza and Appian, are fast to develop and easy to learn, they still require that you have some understanding of programming when you're building an application. So how does RAD Studio fit into all of this? I mean, I know that many of you are Delphi developers and are using RAD Studio, and you're probably asking, well, how does that matter for me? Is this relevant? RAD Studio is, in my mind, is not a low-code quite, but in many ways, the visual development approach that is so common today in low-codes was created by the kinds of RAD Studio applications that were developed early in the century, right? So in some ways, RAD Studio is a pioneer that set the stage for the visual low-code systems that we use today. So while it is not quite a low-code, it does have many of the elements of a low-code. Probably the main differentiation is that to code in RAD Studio, you still need a robust programming language, which is Delphi or C++. You also need a fairly good understanding of tool chains and technologies that are required to enable an application, such as databases. And you need to configure where the servers are. You need to be aware of the target devices where your clients are going to live. The OS is there. And again, RAD Studio hides some of that complexity, but it does require some awareness from the developer so that they can produce the applications at the end of the day. Low code aims to hide some of that complexity. And like I said before, RAD Studio essentially can do anything, whereas low code would probably likely have some limitations because you're not so close to the underlying tool chains, technology tool chains. So how I think about RAD Studio, if you want to sell it, it's easy to think about RAD Studio as the best of both worlds. You have a low-code kind of productivity with visual development, and yet you have no limitations because you can build pretty much anything with scale and ultra-high performance. But it is still a standpoint, a somewhat subjective how you want to position it. But still, I think it's a really good approach. If somebody asks you what RAD Studio and Delphi are, is that it is something like a low code, but it is very robust and scalable. I think it's a very good description. And it sets RAD Studio in really modern terms. So that's very useful, I think. Now, if you look at other low codes, and I picked a couple, OutSystems, very well known, Lanza, also well known, but also a platform that we support. If you look at their visual interfaces, in many ways, they're very similar to RAD Studio. They also have some drag and drop. They have similar ways to configure the applications. You have similar ways to expose both the scripting language together with the visual interface. There is a difference between the different low codes in how much is achieved to drag and drop and how much is achieved through scripting. So that is a little bit of differentiation, for example, between OutSystems and a Lanza. Lanza has far more drag and drop. Lanza is more developer friendly. So depending on what your desires are, both can achieve a lot. They have similar productivity and can do quite well for your needs. Another important part of low codes is that you can extend them. Like I mentioned before, a lot of the low codes are built on top of traditional languages and tool chains. The example here is how you can extend Mendix using Java. A lot of the low codes rely on JavaScript to build their web applications. Those are typically extendable with pure JavaScript, depending on the behaviors that you want to achieve. So there's some nuances here that are important, because as you extend the low code with traditional code, that makes future upgrades tricky. It is important that the low code contemplates how that is done, because maintaining applications that don't contemplate this may be difficult. If you have too many of these extensions and the low code does not support seamlessly getting some of that third-party, if you will, code into the low code, again, that could make upgrades quite problematic. A very important thing to mention when we speak about low codes and RAD Studio in general is that performance really matters. And there are differences when you speak about performance when it comes to the target platforms, target clients that you use in your application. I love this comparison. I picked it up from Zoom, which is in fact what I use right now to record this session, because it shows how a very robust and scaled application can still have a lot of limitations when when you compare the web client and the desktop client. In fact, there are almost 3 times more features in the desktop client versus the web client. So for some of this more complicated recording, which you need to use different windows and manipulate them and drag them around and do different things, you need to use a native client. The web client just does not support it. What does that mean? Is when you go to a low code or you go to a RAD Studio, you can do different things depending on how you target the platforms. And some low codes that exclusively rely on web clients, for example, may have more limitations if you do need to create, for example, an ERP or some other system that needs to have extremely high performance. So definitely something to think about. And we have seen it in the RAD Studio world a lot when back in the day, a lot of people were trying to migrate or upgrade Delphi applications into web applications. They face very significant challenges because they could not replicate the functionality. In fact, I have some examples from the US where one of the largest hospital chains, they literally spent several $100 million trying to replicate a Delphi application into a web application and completely failed. So the money was wasted. So again, you have to think about it when it comes to low code. There are similarities in how people build different solutions. If you're trying to build an ERP, again, probably a very pure web client based low code is not going to be the answer. I want to mention a very specific type of low code or no code solutions because I think they're useful across the board. And those are business process management tools. There are quite a few of those. And I personally love them because they sit on the side of traditional applications, or at least that is how I think about them. So what BPMs do, they are in fact a low code, but you use a process modeling tool, as you can see here, and you can create the flow of the application or the business process and enable it through special forms or different kind of interactions, such as emails and texting and so forth, to enable it. And essentially, you're building an application that is very specific to a task. A good example of this would be an approval. If you want to have a complex approval within an ERP system, sometimes instead of building all the forms in the ERP system, you could use a BPM tool on the side to enable the approval. So you are doing this much faster than, for example, using it within the ERP. In fact, many BPMs like this sit on the side of a system like SAP, but it is something that I think is very useful, even for traditional Delphi applications. If you want to basically enable certain behaviors and don't want to go through through completely programming everything, such tools may be quite useful. So I like them. Lancer has some pretty good functionalities to support this through forms, but we are looking to add this. We already integrate with some of BPMs, and we're looking to add more functionality like that into this low code. But I think it's applicable both for Lancer and other low codes as well as RAD applications. There are a lot of low code choices beyond the ones that are used for business application development. So if you look at this little chart that I picked up, and I forgot where I picked it up from, I think it was some blog, but I find it interesting because if you look at it, there are some of the same low codes that I mentioned in the middle, Appian, Lancer, things like QuickBase, so many of the ones that I mentioned, Kony, Mendix, OutSystems, but then around them, there are so many different purpose-built, essentially low codes. A lot of them are like drag and drop. So you can build an e-commerce solution that sits around an application, and that's in many cases is drag and drop. So you'll see a bunch of these that are out there, very popular when it comes to connectors these days. Many are familiar with Zapier, which is a drag and drop low code connectivity software. So you can configure how you connect your application much more easily than writing the code. So again, a little bit overwhelming when you think how far the term low code extends. But I think that this illustrates well enough that it is something that is very important for us to be aware of. And regardless of what parts of low code you want to use, you're likely going to get some level of exposure to this and use it. Regardless, even if you're, for example, living in a RAD Studio world, some of these low code tools may be applicable for you. So fascinating topic, and I think really, really important for all developers these days. And I want to finish everything with one key statement, which is, at the end of the day, what matters the most is, really what matters the most is that the applications that you build are amazing. But assuming that your applications, you can deliver amazing applications, productivity is the next thing that matters. Because these days, we are all pressured to deliver exceptional ROI. And with ever more complex application development projects, it is not easy. So tools like RAD Studio and low codes really help solve the productivity issue. You use a little bit fewer developers, which results in less costs and less complexity. And very importantly, you can take ideas to market much faster. Fast development also means that it's easier to iterate, and that's one aspect that I feel is very, very important. Obviously, we are all aware of new methodologies for agile development, and that all centers around the idea of quick feedback development. That is a lot easier done in tools like RAD Studio and low codes, because you drag and drop, you show to the business users, and you move forward. Most of these solutions result in less code, which the obvious implications of it is much easier to maintain. I love C++ because it is so powerful, but with C++, I've spoken with many developers who after 2 years cannot read their own code. It is just more complicated, right? With low code and Delphi, it is much easier to read your code, modify it, improve it, and move on. So that's really, really important. Less code supports all of the features that I mentioned before. So that concludes what I wanted to share. I hope that this was interesting. I touched on a number of topics, some in more detail, some in a little bit less detail. My Japanese colleagues said that this is a topic that they're being asked a lot about, and I wanted to share what I know. And again, I hope it is interesting. We can happily answer more questions if needed. Have follow-up sessions. I know that in the next sessions, you'll see a couple of demonstrations, and you'll hear from some of your local Japanese experts that will provide more color to this. I really appreciate the time, and thank you for the attention, and I hope to speak to you very soon. Bye-bye.